Hi, Simge.
Hi, Anand.
How are you today?
I'm doing well, and you?
I'm fine. It's a pleasure to have you here.
Oh, I'm excited to be here. Honored.
Yes. So today my guest is Simge Küçükyavuz. She's chair and David A. Karen Richards Sachs Professor in the Industrial Engineering and Management Science Department at Northwestern University. She's an expert in mixed integer large scale and stochastic optimization with applications in complex computational problems across numerous domains, including social networks, computing and energy infrastructure, statistical learning, and logistics. Her research has been supported by multiple grants from NSF and the Office of Naval Research. She's an Informs Fellow and a recipient of the NSF CAREER Award and the Informs Computing Society Prize. She's the past chair of ICS and serves on the editorial boards of Mathematics of Operations Research, Mathematical Programming, Operations Research, SIAM Journal on Optimization, and MOS-SIAM Optimization Book Series. Simge, thanks a lot for accepting the invitation. Such an honor.
It's my pleasure, Anand.
Yes, so let's start. Simge, did I pronounce your full name correctly? And what is the meaning of your first name?
You did very well, I must say,
Yay.
better than most people. My first name, Simge, it means symbol or icon. Yes, so in Turkish, we usually have names that mean something.
Uh-huh. Where do you come from in Turkey?
From Ankara, the capital.
Mm-hmm. And I heard your parents are professors of chemistry, just like mine. Could you talk more about them?
Oh, yes. So they're both professors of chemistry. Actually, they got their PhD from chemical engineering and decided to be in a chemistry department. So they are engineers by training. And they actually named me, I think I can share the story that, my dad is very much into puzzles. And in Turkish puzzles, they always ask, what's the symbol of iron? Or what's the symbol of oxygen? So that's how my name came about. So my dad's love of puzzles and chemistry and symbols.
Right. So you grew up in an academic family then.
Yes, my sister also did a PhD. So we're in engineering. So we're all a family of engineers.
Wow. Would you like to comment anything else on your parents?
Well, yeah, so they emphasize education a lot. So went to one of the best schools, high school in Ankara. I grew up in faculty housing. So our house was right on the campus of Middle East Technical University, where they were professors and I was inspired to be an undergraduate there. So that's how I chose my undergraduate institution. So very influential. When I growing up, I used to run around in their chemistry labs, and their research assistants used to play with us and so on. So it's just very much a university upbringing.
Right. So they had an influence on the two of you
Mhm.
when it comes to developing an interest in pursuing a PhD, right?
That's right. I mean, in general, in sort of research, education, gaining new knowledge, reading books, and
Uh-huh.
yeah.
Is your sister older than you?
She's a couple of years older than me. That's right.
Mm-hmm. And how much has she influenced you?
Oh, very much. So, I mean, growing up, whenever I had a question or homework, I used to go to her and she would help me out. And then, of course, I looked up to her, and she became an undergraduate in electrical engineering in the same university that I was in. So that got me intrigued in engineering. I was sort of thinking maybe sort of business school and management. I like the people side of things, but then I was, good in math, so I found sort of the intersection of this and industrial engineering. But yeah, definitely she put engineering under my radar. And yeah, so then I watched her sort of apply to US institutions for her PhD. So that gave me inspiration. A couple years later,
Yeah.
I will do the same. So very influential overall.
Yes. So she's like a role model to you?
Exactly. Yes, very
Yeah.
much so.
Yes, yes. I have an older brother, but he's 13 and a half years older than I am. But still,
Okay.
he was extremely influential on me.
That's
Yeah.
right. That's right.
And how was your life outside school? Did you engage in any activities like sports?
I did. I tried some sports. I mean, growing up, I tried a few things. I, took ballet classes, guitar lessons, keyboard, and I played tennis, basketball. was too short for basketball to make it to the team. So then I maybe more consistently I played tennis, but didn't become professional or anything. Just amateur by myself. There was a wall that I practiced against myself. So
Did you have any favorite players at that time?
At that time, I think it was like Martina Navratilova and Monica Seles and Andrea Gassi, so on. So early.
What were your main musical preferences at that time?
So growing up, I think the one that stuck most, I sort of listened to all sorts of music. My youth was the years when Turkey opened up to sort of international influence and music. The radio stations started playing more and more, and then MTV became a thing. So, but my preference, despite listening to multiple kinds, was more like grunge music. So Pearl Jam was my favorite, Nirvana, Alice in Chains, Soundgarden. So those are the ones that stuck with me longer. But I'm very much into all sorts of music. I've listened to, jazz, classical, some heavy metal, even some pop.
Wow. Yeah. Heavy metal.
So just like Metallica, like those days, it was very much popular.
Yes. Yeah. During that grunge movement, I think in the early 90s, and especially when the Nevermind album came out, the 10 album by Pearl Jam, more or less at the time, Metallica put out the Black Album, which was, let's say, more radio friendly. And I remember that I was very young, but
so those are the years, basically. Those would be my early teens, like when I was listening to more of these music. Yeah.
Did you have the chance to see any of those bands live?
Yeah, I mean, again, we don't get many of them to Turkey and definitely not to Ankara. So Istanbul is the social capital, but Pearl Jam came to Istanbul. And I remember my friend and I made a trip to Istanbul, which was a big thing for us to do a road trip as well as our favorite band.
That's amazing. What about movies?
So again, Ankara is a town where there's not much to do besides, hanging out with friends and going to movies. So growing up again, I watched a lot of movies in theaters. My general sort of preferences towards independent movies, European movies, French movies, etc. But I watch all sorts. If I'm in the mood, I would watch a blockbuster as well.
Right. So you're not that much into blockbuster movies or those from Hollywood. You like more the independent ones.
I do watch some of them. So I mean, one thing again with friends growing up is we pay a lot of attention to Oscar. Like we used to stay up at night because of the time difference in the middle of the night to watch the Oscars live, etc. So I do want to know, some of the Hollywood movies that are being talked about a lot. But if you ask me what I enjoy watching most, it's more of the independent movies.
Yes. What did you like to read in those days?
In those days, I mean, some Turkish literature, novels, as well as there was comic series every week that is somewhat political or, everyday events in Turkey, which could be funny. So I really like to read those graphics, and that evolved into graphic novels. I still read to this day. But I mean, literature, some, heavy Russian literature and old books as well, as part of coursework sometimes. But so lots of reading, especially in summer vacations with the comics every week, pretty much.
Yeah, but there was a variety there. You didn't have any specific preference when it comes to books?
Not really, yeah. So again, some Turkish literature that you may not know. Orhan Pamuk is one that is more widely known.
I see. Other than the influence of your sister, who is also an engineer, why did you decide to study industrial engineering?
I think I alluded to a little bit. So I was interested in human side of things. I considered management. Interestingly, I did think about becoming a diplomat or international relations because traveling, seeing different places sounded interesting to me. So I like the social aspect. On the other hand, like I said, I mean, I was very much interested in math and sciences and puzzle solving, problem solving. So I looked into some of the popular majors. So in Turkey, we have a university entrance exam that we have to go through to get into a department. And so I looked at some of the sort of more popular and demanding majors, and industrial engineering is one of them. So you might know there's a lot of Turkish population in industrial engineering, and one of the reasons is this is one of the top programs that we choose in terms of looking for departments and universities.
Right. What was your first experience with OR like? Was it love at first sight?
Oh, yes. So my department, industrial engineering at Middle East Technical University, is very much operations research focused. So we had courses in optimization, statistics, stochastics, and these would be courses where we would actually do proofs and go deeper into the math behind these things, as well as their applications, modeling practical problems. So I was fascinated by how we can use mathematics, mathematical modeling, and systematic thinking to apply to these practical problems.
Right. These courses that you mentioned, they were mandatory or elective? Because it sounded pretty advanced when you mentioned mathematical proofs and so on.
Yeah, they were mandatory. These were like our introduction to optimization, introduction to stochastic processes courses. These were mandatory. I did take graduate level courses, inventory control and production planning because of my interest in applications, but those were electives. But the fundamentals were required courses. And we had required courses in work study, ergonomics, so all aspects of industrial engineering, but the heavier focus was in operations research.
Mm-hmm. Yeah, I see OR as like the backbone of industrial engineering. Do you agree with this?
Yes, I do very much. I mean, I've been in places, universities where we had strong groups of human factors as well as manufacturing, and I think these are also very important aspects of industrial engineering. And historically, this is where industrial engineering came from. But yeah, operations research is, especially these days, the predominant subfield of industrial engineering.
Yes, yes. Did you have to complete any sort of capstone project to graduate?
Yes, we did have a capstone project. It was at the time, Middle East Technical University was thinking about building some technology center to have companies within campus, sort of incubators for potential startups and projects. So there was a question of how to design this building, how to sort of allocate the limited resources space to such companies, and how to make matches between the departmental needs and these companies. So yeah, this was the project that we've done with a group of 3 other students, my friends.
Right. Simge, I know you did your PhD in North America, but did you have a chance to travel abroad before that?
Yeah, my only travel before then outside of Turkey was to US again, and that was a couple years before, essentially to drop my sister to Ohio State University. And my parents found an excuse to sort of be a visiting professor at Louisiana State University. So we spent the summer in Louisiana, and at the end of the summer, we placed my sister to Ohio State University.
Okay. So you already had an experience of visiting the US before. That should have helped. But what universities did you end up applying, and did you receive any mentorship during the process?
Oh, yeah. I mean, these are, again, I'm dating myself, but back in the day, we didn't necessarily, we had internet, I could do some search, but, we used to request brochures and they would mail these big packages and so on. And the previous trip that I mentioned, I knew at that point that I'm going to also apply for PhDs in a couple of years. So I picked up the US News and World Report rankings, graduate rankings from Barnes and Noble or something. And then, so that was my guide. Like that was like, okay, what are the top programs in the US that I can apply to? And I think I applied to many of them. Of course, I talked to my sister, and then I have cousins who grew up in California. They moved from Turkey. So I did seek some guidance from them after admissions, from which school to choose, what do they recommend.
Uh-huh. Are you still driven by rankings? And do you have any recommendations for the youngsters regarding that, who sometimes get really obsessed with top universities
True.
and, you know?
I wouldn't say I'm obsessed, but I think because of my experience, someone who didn't know the US system well, and, that was a guide for me. So I do think they have a place. I do understand their weaknesses. The methodology is not very thorough, especially program rankings. As we say, these are department chairs voting on each other, on a scale of 1 to 5. They are not driven by, I don't know, research expenditures, publications, etc. That's at the college level. So I recognize the flaws. In that sense, I'm not overly obsessed by it, but it is something that people look at, that one should pay attention to, some indicators. So with a grain of salt, yes, I think they have a place and importance.
Yes. Did you have any problems adapting to your new life in the US? I'm asking this because you went first as a tourist. And now
Yes.
you're going to, live there, and it's a completely different story, right?
Yes. I went by myself. I was pretty young at the time, but I actually got very lucky. I got a scholarship from University of California, Berkeley, and the scholarship included sort of room and board in a place called International House, iHouse. Which is this wonderful place where they make sure that there's a group of students internationally from all over the world. So half of the dorm is domestic students, but then half of them are from all over the world. So I made friends very quickly from different parts of the world. I found Turkish friends very quickly. So the adaptation, I would say, was very quick. And Berkeley is a wonderful place to be. Lots of activities. The International House provided a lot of activities, coffee hours, parties, etc. So the dining room was a place that we all got together. And so I also had friends from all over campus, different areas. And so I wasn't limited to just my department.
So the transition was relatively smooth in your case.
I think so, yes.
Yeah. So it
And the classes were similar to what I've taken. So I think it was a smooth transition. A couple years before that was a little of a wake-up call for me, because I thought I knew English well. I spoke, and I had a little bit of trouble, especially in Louisiana. Following the language accent. So that was a wake-up call, and but things worked out well in Berkeley.
Yes, I understand what you're saying. At Berkeley, did you have the chance to meet subject to guests Candi, Yano, and Karen Smilowitz, who, by the way, is your colleague at Northwestern University now?
Yes, small world. So Karen and I took a couple of courses together. So Karen was a Ph.D. student in civil engineering, civil and transportation engineering. I think the department is called Civil and Environmental Engineering, and under that, she was doing transportation. I was in industrial engineering and operations research. So she was taking classes out of her interest. So we met for sure. And then she also did a project with my advisor. So we saw each other, but we weren't very close because we were in different departments at that time. Of course, now we are very close friends and colleagues here. Candi Yano was the department chair at the time when I was a student. So of course, I met her. She was a great chair, really cared about the students. And later on, she became a committee member. So she was on my PhD committee. And even after I graduated, once in a while, I called her up to ask some questions about some challenges I was facing. So yes, very much. And we're still in touch. We see each other at Informs and other meetings.
Awesome. They're great leaders, both of them, right?
Yes, exactly.
Yeah. Could you describe the path that led you to do research on integer programming?
Mm-hmm. Yeah, so as I mentioned in my undergraduate institution, I took these fundamentals of OR. I really liked optimization for sure, but I also liked stochastic processes. So I was sort of open to exploration. So in my first year in Berkeley, in addition to required courses, I took some electives. There was a course called computational optimization. And that was really fascinating to me. So that course really shaped my thinking about research and power of optimization in solving real problems. So that's how I ended up studying integer programming.
You mentioned that you took a course on computational optimization. That brings me to the next question. How was your coding skills at that time?
So I had learned, if people remember, Fortran in my undergrad, but that wasn't as popular anymore. And by the time I moved, people had switched to C. So I had to learn C quickly and code in a more research-friendly manner. So I took courses actually from statistics, so computational statistics as electives, where it was statistical problems but solved using C. So this was, again, one of the influential courses. So that helped me with my research from the beginning, that I could code with C. And at the time, Cplex was in early stages, so callable libraries of Cplex through C, which still remains to be the more efficient way of coding with Cplex or Gurobi now, instead of C++ or Python. So yeah, I wasn't super comfortable, but I worked on it. I knew it was going to be a skill I needed to develop. I took courses on it, and then, I was able to go from there.
That's great. I also used the callable library from Cplex. So at first, it could be a bit challenging, but once you get the idea behind it, you feel that you have superpowers, and
exactly.
and you can boost the performance of the solver, introducing cuts, working with the callbacks, and so on, right?
Exactly. I mean, I think one of the earlier projects I've done, was to introduce my own cut and compare that against Cplex default, and it was like big difference in solution time, and that's exactly when you see your research at work. The callable libraries with C is especially very challenging. I think nowadays with Python, even Java, it's pretty intuitive. So the cost of entry is lower. With C, it was not as intuitive, but like I said, that's where the computational benefits come from. Like, you don't enter the matrix, but you enter the non-zero entries of the matrix, and so
yes,
it was complicated, but once you get the hang of it,
absolutely, I agree with you. Yeah, I still think that one should try the callable library, because you really know what you're doing at a very low level. And of course, you don't have to keep doing that over and over, but because especially the API is improved, right? But I think for the sake of learning, it can be useful.
Yes.
You got your master's degree after doing some coursework, is that right?
That's right. I mean, there's an exam to advance to PhD candidacy, and if you pass that exam, you get a master's. At Berkeley, this is the way. We do the same thing at Northwestern now.
So tell me about your PhD work.
Yeah, so, inspired by that course, and I mentioned to you in my undergrad, I took some advanced courses in production planning, inventory control. Wonderful Professor Nesim Erkip, who's also an Informs member, attends meetings. So I started working on a class of problems known as lot sizing problems. They're integer programming formulations, how to improve those formulations. So I did a polyhedral study of a particular lot sizing problem and developed my own cutting planes and implemented that with C and Cplex. And again, so that I can beat Cplex at that time. And then the research developed from there. So from there, we moved on to more general fixed charge network flow problems, not particularly lot sizing. So this is a more general class of problems, and that involves similar structures. So some network structure, we're trying to optimize flows and networks, but then there's some discrete nature. So in this case, it was the fixed charge nature. And I was able to extend and develop new cuts for this class of problems.
So how was the process of finding valid inequalities? Did you use any software?
At the time, I was aware of software package, academic software called Porta, but I didn't have sort of friends or others who used that. I didn't pick up on it. So I found my own ways, basically. So the particular problem I was looking at had an extended formulation that I could try. And then, there was an optimization algorithm to solve it that was polynomial. So I knew that I should be able to find the convex hull and the cutting planes. So basically, again, I went deep into the theory, polynomial equivalence of optimization and separation, to code a program myself to essentially replicate what Porter would be doing at the time. So yeah, I found my own way, I would say. Later in my career, I did start using Porter and facilitates from examples. I mean, it gives you some idea. You still have to sort of generalize. It gives you some examples and some idea what might be happening, but you really essentially need to understand and develop an argument in theory. And this is what I advise to my students. At least I can't just build theory out of the blue. I always experiment, try some things in either existing package or come up with my own ways of developing an understanding on small examples. And then from there, I try to build the theory by building intuition.
I see. I use Porta during my PhD too, and I use another software called PPL that I think at the time allowed for parallel processing, and the process can be a little bit slow, right, to get the facets and depending on the size of the input. So
there are
useful
the packages now. Yeah, Sage Math has something. The thing is, I mean, I think we'll talk about it, but now we moved on to mixed integer convex optimization when Porta is not as useful, or we don't have a similar package. So we're again back to trying our own ways to find valid inequalities nowadays, maybe cutting surfaces instead of cutting planes. But
yeah, in that case, you have to use your talent, experience, and hard work.
Yeah, I mean, it's surprisingly in one of our recent results, we see that polyhedral theory is still important, but you need to now tie it to this more convex analysis framework.
Yeah, I get it. Do you have any memories of your first presentation at an international conference?
Yes. My first presentation was at an Informs. I don't remember where, but I remember it was on the slot sizing problem I was studying. So, of course, the famous Lawrence Woolsey was in the room. So I was very nervous. And he asked me a question, which I thought I answered. But, I tried to, after my talk, I went and introduced myself and tried to follow up. And so I remember that experience very vividly.
Yeah. You mentioned that you were nervous, but at the same time, that was also a motivation, right? To perform well, and and to have the chance to speak with him in person. The guy is a legend in the field, and especially in lot sizing too, right? He had done a lot of contributions, so it should have felt great for you, right?
It was, yes. As a student, I mean, this was early on in my PhD, so I was very motivated and glad that he was interested to hear my talk. So yes, definitely every Informs I went to. As a student, I mostly went to Informs conferences in North America. So after every Informs, I was very inspired and motivated. That's right.
When you see someone that you admire being that kind to you, that's an inspiration for you to act similarly and encourage the youngsters from the next generation. So I think we should be nice to the community, of course, but especially to the young people. We should nurture the talents. We should protect them and providing support and encouragement. Sometimes giving that little extra attention might have a lot of impact on their careers and also how they see the research environment and the community in general. So I'm not sure if you agree with this. But...
Yeah, of course. Yeah, I mean, I remember also in mixed integer programming, we have mixed integer programming workshops. So they started around the time I was graduating. But after I graduated, I would listen to the students and their posters. And I remember one student telling me, you were the only one who listened to my talks, my presentation. So I do want to support our junior researchers. I think they're the ones who will continue our field. So it's very important to encourage them.
Yes. That's fantastic. During your PhD, you had the opportunity to spend a 6-month period at HP Labs as an intern. What did you do there?
So that was another network optimization problem. They were working on something in communications networks as well as They called it the local area network design. It was a precursor to cloud computing, really. I mean, we didn't have that word back then, but designing this network of cloud computing. So what I did there, my biggest contribution there was they had this network flow formulation. It was a multi-commodity network flow problem, fixed charges as well. So very much along the lines of what I was working on. And I provided a new formulation. So it's kind of an extended formulation that looks much larger, but it really solved the problem fast. And, they were really appreciative of this. We have a patent on this. At the time, we filed it as an intellectual property for how to model this problem. And it was the extended formulation. And I learned C++. So again, we just talked about how I switched from Fortran to C, and I showed up there and they use C++. They do collaborative coding, which I didn't do. I was just coding by myself at the time until then. Yeah, so it was a great experience. I picked up a big C++ Bible and learned how to switch from C to C++, and learned how to commit my code, how to comment better, so other people can understand what I'm doing. So that was a great experience.
Mm-hmm. So after that internship at HP Labs, you returned to Berkeley. Mm-hmm. And how long did it take for you to complete your PhD?
I think after I returned, I returned in January, and by August I graduated. So 8 months, just to wrap things up.
Yeah, you mentioned that Candi was in your jury. Richard Karp was there as well, correct?
That's right. So my advisor was Alper Atamtürk, and so he was the chair of my committee. Candi Yano was a member. And then we have a tradition in Berkeley that we should do a minor, and the minor, a professor from the minor should be on the committee. So I did a minor, and actually we have 2 minors. So statistics was one, I mentioned. I took courses in statistics, and CS was the other because I was interested in algorithms. So Dick Karp was on my committee. It was great to have him, and honor to have him as well.
Mm-hmm. Were you nervous?
I think he's such a nice guy, very relaxed. So, obviously he's a giant, but then you don't feel it. I invited him to be on my committee and he said yes. And then, he had very nice questions to ask that I was able to answer. So I was proud of that. So, I think by then I was more relaxed than my first Informs presentation.
Yeah. So you should have come out of your PhD with full of motivation. You met legends, you did well, made some contacts, had a nice internship, and did a great PhD. Did you do a postdoc after obtaining your PhD degree, or did you find a faculty position right away?
So back in my day, postdocs were not very common in our field. I wasn't aware of any. My papers were in progress. I did research and prepare papers, but they were in process. So I did find a position as a visiting assistant professor, so not tenure track, but a visiting professor at the University of Arizona. So it was mostly a teaching position, but they did encourage me to continue my research. So it was not as heavy teaching load as a normal teaching position, but still heavy coming straight out of PhD. I had to teach 3 semester-length courses. And these were in production planning and facilities layout and optimization as well.
Uh-huh. How long did you stay in Tucson? Tucson, right?
In Tucson, that's right. So I started out as visiting professor, but then later a position opened up and I applied and became a tenure track professor and spent a total of 4.5 years there.
Right. I'm glad you were able to do research. And you have a nice story related to the ISMP conference in Rio, here in Brazil, in 2006,
yes.
right?
Yeah, this is one of the very memorable conferences. So as a visiting professor, I wasn't able to do a lot of research, but I had a research idea. I was working on this problem called lot sizing with backlogging. It was an open problem for 20 plus years, how to find its convex hull. So I was sort of obsessed about this problem. This was the only problem I was working on, except for a couple other things I collaborated on with collaborators in Arizona. And anyway, I think near the end of my visiting professorship term, 2006 was the Rio ISMP, I went to present my results. And in addition to Lawrence Woolsey, Yves Pochet was there, who's also one of the big names in studying integer programming formulations of lot sizing problems.
They
so he
wrote the
came
book
up from my
together,
talk.
right? They wrote the book
Yes,
together,
exactly. Right? Integer programming for production planning, exactly. So he's an expert. He did study this problem for his dissertation, and he could not solve the problem fully, and he had some results. The dissertation was unpublished. So anyway, I presented my results. I had very strong empirical evidence that I have the convex cell. I had the inequalities. But in the convex cell proof, which could be very complicated, there was this one missing piece that I just did not have. So he came right after my talk and said, that lemma is in my thesis. So then we joined forces together and, solved this open problem and published it together. So that was one of these conferences where you really make the connection and solve a problem you've been working on. It was very memorable.
That's an incredible story. You knew him, of course, because of his work on the field. And then he's there attending your presentation, and you have the chance again to interact with one of these important guys. And this time you took to another level and you had a chance to collaborate and prove an important result. That's
exactly.
Just awesome.
First time I met him, I had heard of him, but he didn't used to attend Informs. So then that was at that point, that was my main conference. But he had come to ISMP. So first time I met him, and we immediately started working together and finishing this paper of mine. Yes.
Yes. One never knows.
A lot of people ask me, "Oh, when did you do a postdoc in Belgium?" And I never did a postdoc in Belgium. So this was the story.
Yes, as I was saying, one never knows what can happen in a conference. You have to just go there, show your face, do your best. Maybe you can get something out of it, right?
Exactly. And you present your results in a way that, if you're missing a piece, ask for help. I mean, research is a collaborative process. So
yes.
That was really nice.
Try to make an engaging presentation, invite people to help, collaborate. As I said, sometimes we can have a lot of surprises, positive surprises in the process. Mm-hmm. So it's worth giving a try and not being too shy at times. You just go there and you want to present your work and disappear. Trying to make connections and interact with people that you know from the papers, it's very important, I think.
Exactly, yes. Mm-hmm.
Simge, why did you move to Ohio State University?
Mm-hmm. Very good question. So, this is a little personal. Tucson is a wonderful city, beautiful, but it didn't have opportunities for my husband at the time. So there is a well-known problem in academia, two-body problem. So this oftentimes forces some of the moves. So at the time, Ohio State had a position, and it's in Columbus who offers more opportunities for my husband.
Mm-hmm. Yeah. There you turn attention to optimization problems under uncertainty. How did that happen? You even won the NSF CAREER Award around the time, correct?
That's right. And chance constraint optimization. Sometimes when you look at the CV and the years of publications, it might look like that's where I started this work. But the germs of the stochastic programming were seeded in Tucson because at the time, Surajit Sen, Julia Heigl were at the University of Arizona. And actually, soon after I landed in Tucson, they had the International Conference of Stochastic Programming in Tucson that I attended. It wasn't a conference I would normally attend because I wasn't doing stochastic programming. So that opened my eyes to this sort of world of stochastic programming, and I started interacting with Surajit Sen, who's one of my great collaborators and mentors. But he moved to Ohio State. So he and Julia Heigl moved to Ohio State before me. And of course, Surajit knew I had this two-body problem as well. So when the position opened up, he did encourage me to consider and apply. Uh-huh. So I had started. Surajit had a postdoc, Kai Huang. So we just graduated at the same time. We arrived there at the same time. So he was doing stochastic lot sizing. So we connected. We have a paper together on stochastic lot sizing as well. So the germs were seeded, I think, in Arizona for stochastic programming, chance constraint programming. But the results started appearing after I moved to Ohio State.
Mm-hmm. So again, a conference triggered an important change.
Yes, you can say so. You can say so. Yes.
Yeah, incredible. Would you like to talk about your work on chance constraint optimization at that time?
Yes. So, I mean, at the time, there was a recognition. So Shabir Ahmed, Jim Lutke's dissertation is based on this, and as well as George Nimhauser, one of the other greats in integer programming, that the usual formulation of chance constraint programming was intractable. CPLEX would struggle again. So can we do cutting planes now in this setting? So what happens in at least the version of stochastic programming, chance constraint programming I was looking at the time, based on sample average approximation, is you collect many scenarios, write the full deterministic equivalent, and that's nothing but a giant deterministic integer program. So, I still feel like I approach stochastic programming with an integer programming lens and integer programming tools. So it was a natural problem to look at for me. A lot of the structure in chance constraint programming turns out to be similar to lot sizing structure. There's these things called mixing sets that were studied by Pochet and Woolsey that found their way to chance constraint programming in the earlier work of Jim and Shabir and George. So it was a natural move. It looks very different, but actually this is a large-scale integer program with a lot of the structures that I've had studied.
Yeah, sounds fascinating. And it occurred to me that this could be a good idea for you to provide a very brief explanation on chance constraint optimization for our viewers and listeners.
Of course, yes. So, in much of integer programming, because of its own difficulties, we have assumed that data is known with certainty. And in chance constraint programming, we now know that some parameters are unknown, they're random. Let's say demand for a product and lot sizing is random. And now how should we formulate this problem? There are multiple ways of looking at, depending on what the goals are. And this was, at the time, like I said, I was teaching production planning to undergraduate as well. So there's a famous sort of problem in inventory control that you don't have to meet all demand on time, but you need to have a high service level. So the probability of meeting the demand should be high, and that's your service level. So that's one example of chance constraint programming. When there's uncertainty, you may not be able to meet all constraints feasibly, but you want to have high chance of meeting these constraints.
Yeah, that's the main idea behind it, right?
Yes.
Allow a little infeasibility, but trying to avoid that at all cost.
Exactly.
Right? Mm-hmm. Simge, there have been several ways of addressing combinatorial optimization problems under uncertainty, like stochastic, robust, and chance constraint optimization. However, they not only pose additional modeling challenges, but also the associated solution approaches become more intricate and computationally expensive. Given these complexities, how can we strike a balance between capturing uncertainty effectively and maintaining computational feasibility in real-world applications? It's a long question.
I know, yes. This is sort of the crux of a lot of the stochastic programming research ongoing today as well. Do you do stochastic program where you have to satisfy all constraints, or do you do chance constraint programming? And now there's a move towards distribution robust optimization. Okay, we don't know the distribution. How should we assume that why should we treat the sample as the true distribution, and so on? So I agree with you. There are now even more ways of modeling uncertainty and trying to attempt these problems. And now there's also reinforcement learning and sequential decision making. So I think this is a challenge our community faces, to be able to clarify when each model is appropriate and how to solve the associated problems. I think it's a very active area of research in terms of developing efficient solution methods that people can use. I don't think we are yet in a place where, like CPLEX, here's an off-the-shelf stochastic programming solver that figures out how you want to model and solve. But I think this is what the research is about. Okay.
Do you think that computational work in this field is underappreciated somehow?
I would not say it's underappreciated. So we have journals, Informed Journal on Computing, Math, Programming, Computation, which focus on the computational aspects. They encourage, even our other journals have become more aware of encouraging open source implementations, making the code available. So the barrier to entry is lowered. And if we are just modeling these problems and are not able to solve it, we are not able to show the impact. So I think this is important, and there is appreciation for it. There are some journals or outlets that would really still want to see some theorems here and there. But I think if you target to the right journals and the audience, there's still appreciation for this.
Yeah, because sometimes if you don't put out a theorem or any fancy math, you might struggle a bit to get your work appreciated as it should. So as you said, things are now taking a different direction. And
I believe so. Mm-hmm. I hope so, yes. I mean, and as a chair of Informed Computing Society, I worked with groups to create a new prize, Harvey Greenberg Prize, with some donation and some support from universities, where we encourage that, the work should be computational and show some impact in some application. So there's appreciation for it. And I think it's going to become even more important for our field, for others to adopt these codes and take them further. So I think there are some very worthy efforts, like SDDP software, SDDIP software coming out of Julia, Pyomo, etc. So I think it's gaining more attention, and purely theory paper without any computational backing is also, I think, having difficulty these days. So
I see. Because the more we share codes, then you can help the research process to be more agile. And sometimes, implementing everything from scratch to try just a single idea, it could be very painful, time consuming. And if you're not part of let's say a big group or a group that has been doing that for a long time, you are sort of left out of the scene. And I find it that researchers are too protective at times of their code and everything. So I think we should encourage this type of attitude in the sense of providing means for the other people to contribute in your field, as opposed to try to protect it to a certain extent that just a handful of people can dictate what comes next, right?
Exactly. And I think there's a push towards this. Like I mentioned, even operations research now is pushing in this direction. And I think it's also good to think about the impact. So if you make your code available and people are able to use it in their research, then they can cite your code, and we should encourage these kind of citations as well. So I encourage my students to put their code in GitHub, make it available, and same with the journals. We share the code with the journals these days. Yes. I think there's a shift in this thinking, just because of the CS community and statistics community. For them, it's very common to share the code, and it's great if people use it and cite it. And that's the way to think about it, I think.
Yeah, to embrace their policy within our community would be more productive. And I had a very interesting discussion about this with Ted Rolfs in a previous Subject to episode. So I highly recommend.
Yes, very much leader in this CoinOR, making these software available, as well as easy to use also. I think this is also going to be important, because our codes get a bit complex. Of course, for example, we talked about Cplex and also Gurobi now. Those are licensed software, so it's not fully open source in some cases, but at least the portions that we can share, we try to share.
Yeah, the software engineering component of this discussion is really meaningful, and we should not overlook that aspect as well. Simge, you moved again to Seattle this time to work at the University of Washington. What was the motivation?
Well, most of my motivations are the two-body problem I mentioned. So Columbus, Ohio was sort of a compromise solution. So my husband is in high-tech industry, and he wanted to work in high-tech, and so wanted to work at Microsoft, and that's how we moved. At that time, remote work wasn't very popular. So, and University of Washington had a position. So I applied, and he also found a job at Microsoft.
Your period in Seattle was brief, but still very productive. It was there where you started working on statistical learning and mixed integer convex optimization problems. What motivated you to do so?
Well, I mean, one of the attractions of University of Washington for me was a super strong CS program, very well known, top ranked. as well as statistics. So they were very much into early years, but they were very much into machine learning, data science, statistical learning. And that was a motivation. By then, I knew that there's something there that we can contribute as integer programmers, but I just did not know the area that well. And this is sort of an incubator of these ideas. So I quickly connected with a colleague in biostatistics department who was interested in problems in graphical models, probabilistic graphical models, which is nothing but the kinds of problems I've been working on, like network optimization problems. And we had a student we jointly advised. And so that is a great collaboration. We still continue. I just met him yesterday. So, and the problems turn out to be network optimization problems, but with a convex objective. So that was new to me at the time, that I've been looking at mixed integer linear programs. Even in stochastic programming, most things turn out to be linear, at least the ones I looked at. Yeah, so that was my first foray into, in theory side, mixed integer convex optimization, and in application side, statistical learning, graphical models, Bayesian networks, etc.
Very nice. It seems that you had a great time in Seattle. I heard you did a lot of hiking as well. Why haven't you stayed longer?
So yes, Seattle is a sort of a hidden gem. It's a wonderful city, lots of outdoors activities, hiking and lake. I've done paddle boarding and kayaking, etc., and enjoyed my time there. I talked about my interest in grunge. So Seattle is, of course, where grunge rock has started from. So I always had a place in my heart for Seattle from growing up. Well, one day I received a call from Northwestern. They were looking for someone in integer programming, and it was something I wanted to explore. So that's the story. I mean, part of my story is I have a hard time saying no. So I pick up a call, I keep an open eye for opportunities, even though I'm happy wherever I am. So it worked out this way.
Uh-huh. You joined Northwestern University about 6 years ago and have since extended your work on mixed integer convex optimization problems. What have you been specifically investigating in recent years? And could you highlight a couple of promising research directions or open questions that you believe are worth pursuing?
Mm-hmm. So I told you that the application side, the statistical learning models came from my research at University of Washington. But in terms of mixed integer programming theory at the time, there was some work on mixed integer convex optimization. But, I've seen through my dissertation, I've seen how CPLEX and later Gurobi improved in solving mixed integer linear programs. So a lot of theory has been built on this linear polyhedral theory for linear mixed integer linear optimization. And I found the theory lacking in the mixed integer convex space, especially the structures that I was looking at. There were people starting to look at some of the problems, but with certain assumptions, in the case of these mixed integer convex quadratic optimization problems with indicators. So these are the problems that motivated me, statistical learning problems, where you decide whether a continuous variable should be 0 or non-zero, and that's an indicator variable that indicates that. And there's a quadratic penalty loss function in learning. So I found the theory needed a lot of work, and I find it very exciting because I think the next generation of optimization solvers, the next generation of CPLEX and Gurobi, will now incorporate the theory that we're building right now to mixed integer convex problems. So cutting planes for mixed integer convex problems, it's already happening right now. There are some developments in Gurobi that incorporate the earlier work to the software. But again, this is the early stages for mixed integer convex optimization.
Yes. I think Express also has been making substantial progress in that regard.
Yep. So that's so I'm part of a group of people looking at these class of problems. Yes.
Yeah. I think the entry barrier is a bit higher when it comes to nonlinear optimization in general. But I sense that many people that were originally doing mixed integer linear programming are now gravitating towards the nonlinear problems.
This is true, yes.
Especially when you want to model engineering problems and you have those formulas that you just can't linearize that easily.
Exactly.
Right?
Mm-hmm. And non-convex as well. For now, I've been sticking to convex problems so that the continuous relaxations are tractable. But yeah, I think this is the next frontier in terms of mixed integer programming. I'm not saying mixed integer linear programming is a solved problem. It's still NP hard and very difficult. But in terms of opportunities to advance knowledge, I think mixed integer convex opens up a lot of the open problems.
Mm-hmm. And it opens a lot of room for collaboration between different disciplines.
That's right.
Simge, after many academic roles over the years, you now find yourself as department chair. How has the experience been so far?
It's different. It's interesting. It's good. So I've been a chair for a little over a year now. And, it's the other side that you don't see or pay attention to when you're a faculty member doing your thing, your own research and teaching. It gives a better overview as to how things work in a department and across a college. So it's been a learning experience. It's been a satisfying experience. I had to do a strategic planning exercise last year to chart the new direction. So it's very exciting time for thinking about our field, my department, how it fits into the college and to the overall activities in data science and machine learning and AI. So it's been good, but there are some new aspects that I had to learn and deal with.
Uh-huh. I'm glad you're seeing this as a very positive experience. Many people they struggle when they occupy these positions. A lot of things at stake.
It was a hard decision.
I mean, a lot of things at stake. I myself, I don't think I have a knack for that, but I'm glad that you have found your way and you're having a nice time, although it's a lot of work.
I should warn you, there was a time I used to say I will never become a department chair. So it's not something we usually think about. But yeah, I mean, I think it was a time when I had to step up to the plate. And
Simge, you have an extensive editorial activity. What are the main changes that you have observed throughout the years in this context?
Mm-hmm. Yes, I was an AE in many journals. I refereed many papers as well. What I'm observing over the years is I think our papers are getting a bit longer, maybe even sort of out of focus. We used to have one main idea and a paper built around this main idea, and now we have to do multiple extensions and pages and pages of computational studies and so on. So I think this is affecting, it's getting harder to find referees. The papers are getting longer. It's taking longer for referees to be able to review such long papers in any great detail. So that's a trend I recognize that we might want to think about as a profession. There are already some conversations. Some editors-in-chief started conversations around this. How do we get higher quality referee reports? Sometimes referees ask us to do many additional things that are beyond what was planned. So, what is the role of an AE in this, an editor-in-chief in this? So I think these are the discussions we're having right now, but I did definitely notice increasing length of time to review, and finding difficulty in reviewers.
Finding reviewers is like a general problem, I would say.
Everyone is stretched too thin. I mean, we have our research to do. This is a volunteer work. There's not too much motivation. I mean, one of the ideas being discussed is how can we motivate? Some best referee awards are being discussed. That could be helpful. But yeah, it's usually unappreciated work. My rule of thumb is if you are submitting papers for others to review, you should accept reviewing yourself. And one of the calls is when an AE invites a referee. If you're not able to do it, at least hit the decline button. We sometimes don't even get that. So getting people to agree or disagree and then decline, or then find enough number of referees for a paper. These are the things we need to work on as a profession. I mean, we don't have the conference proceeding culture of huge numbers to review in very short times, but then we need to improve still the evaluation time and the quality of the reviews.
Yeah. Suggesting reviewers is very important as well, I think.
Yes, I mean, even if you have to decline, suggesting who else might do it helps an AE a lot and helps the process move along.
Do you think that researchers have become overly obsessed with academic metrics?
I think so. I think with the easy access to these metrics with Google Scholar, And the pressure may be coming from the dean's level or the university level, how to assess impact. So I don't know that the pressure comes from the academics themselves or outer evaluation metrics for promotion, tenure, and again, easy access to Google Scholar made things a bit more prominent in the past few years. Again, this is something that we see the change over time and the last 10 years, I would say.
Are you worried about this?
Well, I come from a community. Integer programming is a small community, so we are not too obsessed with this because impact factors, number of citations, is often a sign of the community size as well. I mean, in machine learning, these citations are off the charts compared to what we get in operations research and optimization. Integer programming, especially convex optimization, has applications in machine learning and has benefited from that. So I myself don't obsess over it. I don't pay attention to it when I have to write tenure letters. I know the caveats, so I don't pay too much attention to it. But I do know, I see from now as a chair that this is attracting a lot of attention in certain circles and more in the deans and university level.
Mm-hmm. Do you think that this can play an important role when someone is picking a field I'll study this because I can have this very nice profile on Google Scholar with, many citations and people will find it cool. So do you have any comments on this?
Yeah, I mean, I think there may be some researchers who overly focus on this and pick their topics based on this. I mean, I've always done what I'm interested in without having to worry about, of course you want to make impact and want people to be interested in what you do, but that hasn't been my main focus in choosing a problem to work on. But I do see people worrying about this in terms of what they want to study.
Competition is now more prominent compared to a couple of decades ago. So that is also encouraging this type of behavior.
Exactly.
And sometimes it's hard for us to put ourselves on the place of those youngsters that are now struggling to get a position and end up doing multiple postdocs until they find something. So, and
that's true. The CVs are getting longer. Sometimes PhD student applicants for faculty positions have CVs that would be better than a CV of an assistant professor 40 years ago and so on. So yeah, the bar is getting higher in terms of expectations, in terms of number of papers, citations. We have people looking at citations of PhD students for faculty positions. So yeah, it is something that has changed, a trend that I'm seeing as well, but I am not overly worried about this.
Right. Simge, now changing topics. Do you think your academic and professional trajectory was made more challenging in any way because of your gender?
Of course, there are fewer people in STEM who are female and with other identities. So there have been times when I was the only woman in the room in a workshop or a conference. And, sometimes they say you have to work twice as hard to get half the recognition. So I think changing that, having more women in places of leadership as well, and our student body is important. Obviously, I haven't seen any direct effect, but it is true that there are fewer women in the field and that affects our recognition. So with this in mind, I try to serve as a role model. And I think, taking a leadership role, I've heard from some younger women say, we look up to you and your leadership and being an example. So you can't be what you cannot see is what people say. So I try to at least set an example for the next generation. I try to encourage them. I often take a call from some of my colleagues who ask questions about how to deal with a situation. So it is a concern, but I think it's improving. And, we just need to, what you're doing is great to feature women in your podcast and ask about these questions directly, these challenging questions. So hopefully there's improvement in this in our field.
Yes. I also expect that. And of course, you're doing a great job in that sense. Simge, what are your plans for the future, both in terms of work and hobbies?
In terms of work, I am very much continuing my work in mixed integer convex optimizations, applications to statistical learning, mixed integer nonlinear programming, submodular optimization, something I didn't talk about, but I'm passionate about. Currently working on a book with some colleagues, long-term project, let's say, less time to work on it these days. And of course, continue my term as chair. In terms of hobbies, I really like traveling, exploring new places. And one of our goals, my husband, is to go to all the national parks in the US. So I think we're somewhere halfway through in that. Hiking in the mountains, exploring nature as well. Those are the plans. So I'm going to Colombia this December for a workshop, and yes, a couple other travels coming up.
Very promising. So would you like to share a final message with our viewers and listeners?
Well, first of all, thank you for doing this podcast. I think this is a great service to our community, and I enjoyed being part of this adventure. And I think my suggestion, as you can see, I had a nonlinear career path, and I would encourage everyone to follow their own path, wherever that leads. And, you know, just as long as you like what you do, and you'll be fine. You'll find your own success in your own way.
Yeah, very concise, but I liked it. Yeah. Simge, it was a pleasure to have you here. Very entertaining. I had a great time. Time just flew. So thank you very much for your time.
Thank you, Anand. I also had a great time. It was my pleasure to share some of my experiences. I hope people find it interesting.
No, absolutely. And you mentioned that you like traveling. Please consider putting Brazil and João Pessoa in your plans. We'll be very happy to host you here.
Love to, yes.
Okay, once again, thank you so much. Take care and see you soon. I hope to meet you in person one day, Simge.
I hope so too.
Bye.
Thank you very much.
Ciao.
Bye.
Bye.